Hi everybody, this is Katie, and I'm going to make a quick video on how to do parts of our lab, which is on subnetting, IP networks. Let me adjust my sound here, sounds a little strange. Hopefully it's good for you. So you've been going through here, and in chapter 7 you learned about IP addressing, IP version 4 and IP version 6, and you watched a couple videos that Professor Rosema did. I do want you to watch this video on chapter 8. The video he refers to as chapter 9 just because there were some small changes that Netacad did when they updated the curriculum. But his video is still pertinent and you should watch it. It's pretty short, 20 minutes or so, on chapter 8. And then we have 2 assignments plus the quiz exam. One is a packet tracer, subnetting scenario 1, that's in the book. But to help you with that, I want to do a little practicing on how to calculate IP4 subnets so that you can do the packet tracer and you can better understand subnetting. So I've given you this PDF. Download it. That's the one that you're going to turn in. Only one for this lab. The normal 3 for the packet tracer. And I want to make this video to show you how to do this. I got a couple emails. I know subnetting is hard. By the time you are finished with your CCNA curriculum, though, you will completely understand subnetting IP version 4 and IP6 as well. It's all throughout the curriculum, and really this is your second introduction to it. So no worries too much. Hold on. Okay, my sound sounds strange still. I'll quit moving around so much. Okay, so this is where we're starting. I want you to take a minute, pause the video, and read this part 1. There are 6 parts to this whole lab, I think. Let me take a look real quick. 7 pages. Oh no, there's only... Jeez. Oh, there's not 6 parts. There's only 2 major parts, but there's 6 or 7 different problems that we're going to do. In part 1, it explains to you binary ANDing. This is from chapter 7. So when you were in chapter 7 and you are reading and watching videos about IP4 structure and how to figure out the network address, we used binary ANDing. So you might want to go back to section 7, 1, 2, 3 to see how that works. And it basically compares an IP address and converts it to binary, and then it takes a subnet mask and converts it to binary, and then it compares the differences. So with the binary ANDing, when there's a 1 and a 1, it's a 1. Anything else is a 0. So when you are comparing the 2, you're comparing this 1 to this 1. This bit to this bit here to this bit here. And because those 2 match, then it's a 1 and a 1, and the rest don't, so it's zeros. That's how binary ANDing works, and it's helpful to figuring out what the network address is when you have an IP address and then a subnet mask. So read that section again if you need to before you go on. This section here explains IP addressing, ANDing, and then what you're doing with this assignment. So read through that. Look at these 2 formulas here on how to figure out the number of hosts. And then where we're going to start is right here. Whoops, I jumped ahead on my assignment there. Okay, so you've paused it, you've read through it, you know a little bit of background now for this lab. The first address we're going to look at is here, and we need to figure out the network address, the broadcast address, the number of bits, host bits, and the number of hosts that we have. So when I calculate things like this, I use a table because it helps me to keep track and calculate things. So I'm going to pull up my calculator here, And I have also my Excel spreadsheet that I use for this lab. And I'll post this Excel worksheet out in Blackboard too. It might help you. All it is part 1, address 1, address 2, address 3, 4, 5, and 6. There are these 6 addresses right here. And all I did is put the IP addresses in this first spot, and then I'm going to fill in the rest and show you how I do that. This conversion table, I put this up here because this is how I calculate binary or decimal to binary. So with my conversion table, I use this. You take 128 and you divide by 2 and you get 8, divide in half all the way down and you get 8 places. So all you have to do, if you want to convert any decimal to binary or binary to decimal, all you really have to remember is this table. And you just start with 128, divide by 2, 64, divide by 2, 32, divide by 2. So what we have there are 8 different places, which represent the 8 bits. So if you have a binary stream and you want to convert it to dotted decimal, so say you have a binary stream of 11001010. So that's 8 bits, right? So anywhere there's a 1, you put here. Anywhere there's a 0, so we're going to 11001010. And then if you want to find out what the binary equivalent is to this binary stream, the decimal equivalent, excuse me, anywhere there's a 1, you add it up. So you add 128 plus 64. I don't know what Excel is doing. 128 plus 64 plus 8. I thought it was that. Okay. 128, 64 plus 8 plus 2, because that's all the places that there are 1. And that comes out to 202. I'm looking at my sum down here. So the binary equivalent, or the decimal equivalent to this binary stream is equal to 202. Right? Now you can also, so any 8-bit binary stream you put in there and you'll find out the decimal equivalent. You want to check it, use your calculator. Here's my calculator. I'm going to take 202 and look over here. I get the binary 11001010. Okay, 202. Now if you want to take and go the other way, you can use 192, 168. You can take any decimal number and figure out the binary equivalent by using subtraction and not addition. So if I want to figure out the binary equivalent of 192, then this is, I don't have a scratch pad up, but what you do for this is you subtract. So you would do, could you subtract from 192, can you subtract 128 without going negative? So you do that math, 192 minus 128. You can do that without going negative, so you put a 1 right here in that first spot. And then you go to the next number and you look at what you have left. Okay, so I have 64 left. Could I do 64 minus 64 without going negative? And you can, so you have a 1 there. And then the rest of them were zeros, so that goes out to 0, 0, 0, 0, 0, and 0. So the binary equivalent to 192 is this, 1, 1, 1, 2, 3, 4, 5, 6. That's the decimal equivalent. 168 is 128 plus 32. So let's just clear this out and we could do another example. I gotta use my calculator so I don't publicly humiliate myself with my inability to do simple math. But let's say 168 minus 128, because that's where we're starting. Can we do that without going negative? We can, so we put a 1 there. And you'll notice I had 40 left. So can we subtract 64 from 40 without going negative? We cannot. So we'll put a 0 there. And now we have 32. So can we subtract 32 from 40 without going negative? And we can. So this goes 1, and we have 8 left. So this becomes a 1. And we have 8 left. So we know we can't do 16, but we can do 8, and then the rest are 0. So the binary equivalent to the decimal number 168 is 101010000. 100. Do you see how we're doing that? Now these little tables are so handy. Let me clear these contents. If you understand that, then it helps with subnetting because you're looking at binary and bit borrowing, and it really does help. So there's a lot of different videos, different examples online on how to convert binary to decimal and decimal to binary. But figure that out because it'll help you in the long run. So I have my conversion table up here that I keep just for reference. Okay, so back to the problem. We're going to figure out the network address, the broadcast address, the number of host bits, and the number of hosts. And all we're given is this number. And let me just double check my IP because I had it wrong before. And I had to start my video all over. Okay, so I plug that in. I'm going to figure out what I'm working with. So first of all, let's figure out our subnet mask. And that we can tell based on how many bits, based on that prefix number. So if I have a /28, that means that there are 28 bits are in the network part of the address. So if I have 28 bits that are in the network, how many host bits do I have? Remember, when you look at an IP, there's a network part and there's a host part. So if 28 bits belong to the network, all you do to find out how many host bits you have left is 32, because this is a 32-bit stream, minus the prefix, which is 4. So how many host bits do I have? I have 4. Okay, 32 minus 28. So the other way to figure that, or from that, we can also figure our subnet mask. So if I have 28 that are part of the network, that means that my subnet mask is going to be 28 ones in a row. So there's 8. Right? Here's 8 more. Here's 8 more. And now I need, how much do I need more? 4, right? Because I have 8 plus 8 is 16, plus 8 is 24, 25, 26, 27, 28, and the rest are zeros till I get to 32. So this, I just take that, all of those 28 bits, and I make it my subnet mask. Same with this one down here. Looking at question 2, I can ignore everything right here. If I want to find out what my subnet mask is of this IP address, look at this 30. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 for my zeros. Okay. Go to the next one, 19. That's what my subnet mask is going to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Stop. I almost kept going. 19. So now I'm going to zeros. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's my subnet mask. Now, computers don't read binary streams, they read decimals, so we're going to convert this. You can use your conversion table up here. Anywhere there's a 1, put a 1 in there. That will add up to all 8 ones right there, adds up to 255. 255, 255. Oops, I'm on the wrong address even, but that's okay. Let's go up here. Here's more ones. 255, 255, 255. Okay, what's this one? Well, 1, 1, 1, 1, 0, 0, 0, 0. Anywhere there's a 1, I'm going to add up. So I highlight my numbers. I'm looking down here. I have a sum of 240. So my subnet mask for this IP address with the prefix of 28 is 255.255.240. What's it of prefix 30? 255.255.255. I have 2 more ones. Down here at my sum, 252. And by the way, anytime you look at a subnet mask and it has -28, it's always this is your subnet mask. If it's -30, it's always this is your subnet mask. Subnet masks duplicate. They're the same all the time, depending on how many bits you borrow. Once you remember that, once you see slash, say you see /24, you know it's 255.255.255.0. That one is a given. If you'll memorize these after a while. 19. So this is 255.255. No, this one isn't 25. It's 1, 2, 3. So we're going to just do the first 3. Going back up to my conversion table. And I just highlight those, and Excel does this little total down here for me, so that's 224. So /19 subnet mask 224, and then there's zeros here, so that's all zeros there. Now the next one down here, we might as well do all our subnet masks since it's good to duplicate and replicate and do over and over. I already told you 24 was always 255.255.255.0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay? 255. 255, 0. That's /24 prefix. Address 5, /22. Did we do 22 already? No. I hope this is making sense. It should be. So again, repetition. Repetition. It's good. We're going to do 22 ones. 1, 2, 3, 4, 5, 6, 7, 8. I think I did too many there. And by the way, why I'm doing 8 per block is that's your octet. It's 4 32-bit streams. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and the rest are zeros. Okay? So we know that's 255, 255. See that 6 zeros is what? 6 zeros, I'm sorry, 6 ones is what? 1, 2, 3, 4, 5, 6. What's that? Equal 252. Same as this one, right? -30 was 252 in the last. -22 is 252 here. And then a 0. One more to do, -27. So 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 255, 255, 255. 3 bits is 224. Okay. So we have our subnet masks figured out. That's the first task. Because then from there we can go on to the next thing. I'm going to erase this because well, I'll leave that there. I'm going to leave my subnet mask numbers there because that's going to help us with our binary ANDing. Okay, the number of host bits. What I just explained before we went into subnet mask is the number of host bits is equal to how many bits you have part of your network, and then we're wanting to know how many are part of the host. So there's 32 in total. If 28 are part of the network, there's 4 part of the host. Coming down here to address 2. I should have saved a copy of this before I'm typing in all my answers, but if you want a copy of it. So 32 minus 30, we have 2 that are in the host. 32 minus 19, that is 13 that are part of the host. So 19 of the bits, that means 19 bits are for the network part, and 13 are for the host part. Remember, you look at an IP address, and part of this defines the subnet or the network. The other part defines the host. In Chapter 7, when you looked at IP addressing, it was just no subnetting. It was one network of 254, or one network of 65,000, or one network of 16 million. It wasn't breaking apart any network. So we need to know how to do this for subnetting. Okay, so address 4, we have 24 bits minus 32, so 8 are for the network. And then 22 for address 5 to 32, so 10. And then 27 left there, so that leaves us 5. Oops, not 8, 5. So let's try to stick with one problem now instead of jumping all over. But we're seeing how we can figure out how many hosts. Now, by the way, that is this in the homework the lab. We just filled out this table right here. There's no place for subnet mask. We didn't do that yet. Or we don't need to write that in the table. Okay, let's figure out what our network ID is. Now this is where binary ANDing comes into place. So it's explained up in here, up in here, up in here. That's my singing. Ha! So we have an IP address, we have a subnet mask. We have that now. And you can only perform binary ANDing on an octet that does not have 255 or 0 in it. If it has a 255, it's the same. If it has a 0, it becomes a 0. So what that means is we're going to compare this address with this address to come up with our network ID. If it has a 255 in it, then it stays the same as what it was. So this is 192. The next one, 168. The next one, 100. Because that stays the same. So now we want to find out this last one because that's not the same. So you can only perform network binary ANDing on those that do not have a 0 or 255. This doesn't have a 0, 255, so we're going to perform binary ANDing. And how you do that is you compare the binary equivalent of these decimal numbers. So we already know 240 is 11110000. I'm going to compare that to the decimal or the binary equivalent of 25. That's my number I'm looking at. Now, show you how to use the calculator as well. I'm going to go to Programmer. I'm going to go down to, I'm just going to hit 25, and then it shows me what the binary equivalent is right here. So that, let me move this over here so that I can plug that in. I could have done the math up with my conversion table, but this is a little shorter. Okay. And let's do 100 just so we have our tables completed. Let's see, the binary equivalent of 100, that's a decimal number. The binary equivalent is 011000100. Okay. So what we're looking at is this thing here, the decimal equivalent and the decimal equivalent of 25 compared to 240, because we want to find out the network ID. So we're going to do binary ANDing. Remember, that's from chapter 7. I pointed out earlier, this section where there's matches, anywhere there's a 1, it becomes a 1. That's how we can figure it out. If it's not a 1 and a 1, then it's a 0. So I'm trying to figure out what this number is here, and I'm comparing this 0 to this 1. So not a 1 and a 1, so it's 0. And then I'm comparing the second 0 to the second 1, so that's a 0. The third 0 to the third 1, so that's a 0. The fourth 1 to the fourth 1, so that's a 1. Binary AND happened right there. And then I have a 1 to a 0, a 0 to a 0, a 0 to a 0, and a 1 to a 0. So the rest of them are all zeros. Okay, so what is the network ID for this? Well, we just have to plug it in up here. 0, 0, 0, 1, 0, 0, 0, 0. Anywhere there's a 1, we add it up. So our network ID is 16. Voila! That was easy, right? Yes, very easy. Let's take a look at our second one. Oh, I am going to keep going down because I think repetition is helping. It's helping me because I do subnetting a lot, and I always practice it, and it just helps over and over. Okay, we don't care what the binary numbers are for that, but let's find out what the binary number is for 130. Well, let's start off here. 255, so this stays the same. 172, 255, so 30 stays the same. 255, so 10 stays the same. 252 is different, so we're going to look at 130, right? Now, let's look at the decimal of that. So 130, the binary, I keep saying the wrong thing. The binary right here is 1, 0, 0, 0, 0, 0, 1, 0. Okay, let's match them up, and then we'll find the network ID. So 1 to 1, so we got a 1. 0 to 1, 0. 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 1, 2, 3, 4, 5, 6. Now we got 1 to 0, still a 0. And we got 0 to 0, still a 0. So what's this equivalent? Go up to the conversion table, putting a 1 right in this spot. And guess what? It's 128. So the network ID here is 172, 30, 10, 128. Okay, you see how we're figuring all of this out just by looking at that prefix. Then from there we can say how many are in the host, how many are in the network, what is our subnet mask. We're figuring out a lot of stuff. Address 3. 255, so our network address is 10. dot 1 dot, let's hold up a second. What is this? 224. All right, so let's look at 113. Clear, clear, clear. 113 in binary is this. 0, 1, 1, 1, 0, 0, 0, 1. Okay, let's do our binary and, oh darn it, I put that in the wrong box. 0, 1, 1, 1, 0, 0, 0, 1. Let's do our binary ANDing where we're comparing this box and this box. So 0 and 1 is a 0. 1 and 1 is a 1. 1, okay, we're looking at this third one, and this third one is a 1. Then we're looking at this fourth one and this fourth 0. So that's going to be a 0. And then the rest, we don't have any 1s down here, so the last 4 are 0s. Okay. What is the decimal number? I put that in the wrong box too. What is the decimal number of this binary stream? 0, 1, 1, 0, 0, 0, 0, 0. Well, let's see. We had 0, 1, 1. Add those two together, we get 96. So address 3, the network ID is 10.1.96. And then when there's a 0 in the subnet mask, there becomes a 0 in that network ID. It doesn't take on this because that's part of the network. Or that's part of the host, not the network, sorry. That's part of the network. So that becomes a 0. I think you're getting it. I think you can do this 4, 5, and 6 on your own. I'll go through without as much talking and just show you 198, 133, 219, and then we have a 0 here, so the network ID here is a 0. We don't even have to convert anything. That one was easy. Our network ID for address 5, which started out as 128.107.14.191, becomes 128.107. Okay, 14. Let's do it this way. Clear. 14. Okay, that when you have something like 4 numbers, that means there are 4 leading zeros. So the binary equivalent to 14 is 1, 2, 3, 4. 4 zeros. Then 1, 2, 3, 4. There. So we have 8 numbers. And then I can look at matching ones, figure out this subnet. So let's see, the first 4 are going to be 0, 1, 2, 3, 4. And then it looks like we're going to have 2 1s and 2 0s. And then that, I don't do so well going backwards, but let's try. 1, 2, 3, 4, 1, 2, 3, 4. That's my decimal number. 12. Or use the table up here, which was 0, 0, 0, 0, 0. Nope. It was 0, 0, 0, 0, 1, 1, 0, 0. 8 plus 4 is 12. So that's where we get 12. And then there's a 0 here, so 0 there. Network ID for address 5, 128.107.12.0. Last one, 172, 16, 104, 224. All right, let's look at 99. Go back to decimal, clear this, 99, 0110, 0011, 011. And we have 224 up here before. 0110, and that was 96. 0110, which would be those two. So this 96. So address 6, the network ID 172.16.104.96. Okay. That is all of the boxes for the network address. Going on, let's look at the broadcast. Well, let's do the number of hosts. This is a simple formula explained right here. You take 2 to the power of the number of bits that you have in your host, the number of host bits, and you subtract 2. So for this first one, you would do 2 to the power of, are we on the right one? Number of bits, 4. And then you subtract 2 from that. So what does that equal? 2 to the power of 4 is 16 minus 2. So we have 14 hosts on each one of our subnets. That's what that means. Number of hosts. What's the number of hosts? This one is 14. Okay? So here, 2 to the power of 2, which is 4, minus 2 equals 2. Lots of 2's there, but we have 2 in the second box. Go down to address 3. 2 to the power of how many bits do we have in our host? So 2 to the power of 13. 13. 2 raised to the power of 13 minus 2. It's going to tell us how many hosts we have, and I cannot do that without my calculator. So I'm going to go back to a standard. No, scientific will work. See this x over y? That's how you can raise 2 to any number. So let me clear myself out. And then 2 to the power, and then I hit this button, x over y, or x under y, and then I want to raise it to the power of 13. And that's 8,192 minus 2. And there's my answer. 8,190. Okay. Okay, resuming. Part 1, address 4. 2 to the power of 8 minus 2. Writing out this formula so you can see how it works. 2 to the power of 8 minus 2, 254. Which I could have guessed that because this whole address, this whole network ID is left over for hosts, so 254. Address 5, that's going to be 2 to the power of 10 minus 2. Comes out to 1,022. And then the last one, 2 to the power of 5 minus 2. 2 to the power of 5 is 32. Minus 2, we have 30. So here, on each of our subnets, what this means is we have 30 computers on each of our subnets. Last thing we need to know, broadcast address. So let's look up at the top. Let's start over. It's always the network ID plus the number of hosts plus 1. So what my network ID is 192.168.100, and then my broadcast address is going to be, here's my network ID, so I'm going to add how many, let's see, I'm going to add how many hosts I have to it, which is 14 plus 1. So 16 plus 14 is 30 plus 1, because I want to use the next address, which would be my next ID. The next available ID, that's what's reserved for my broadcast. So that would be 31. So my broadcast, again, is always the network ID octet, the one that you're changing. So this 172.30.10. And then I'm going to take 128 and I'm going to add 2 to it, which is 30. And then I'll add one more to it, so it's .131. Because 2 is how many hosts we have. Okay, address 3, the broadcast, 10.1. Now we change it here. We don't change the last one. The last, well, that one, well, we'll talk about that in a second, but let's look at 96. We're going to take 96 plus 13 plus 1, because that's how many bits? What are we on? 3. So 96 plus 13. Now you could just add 14. Oh, I'm not sure. Hold on one second. Where? Oops, sorry. Okay, that method, when you get to the subnet mask that isn't in the last octet, it's done a little differently. So let's come back to 3. Let's look at 4. We'll come back to 3 and we'll finish that in a second, because 6 is the same and it's easier to explain on 6. Address 4. So here we are looking at 198.133.219, and here we have 0, so all our broadcast is 255. It's 254 plus 1, which is 255. And then let's see, 5 is kind of the same way. So our broadcast here is 128, 107. Now this one is now 15. That's our broadcast, because we borrow bits. And then 255 for the 0. Now to help explain why that broadcast message is 15 for that one, if we look at down here, 172, our broadcast, 16, 104, and then 96. So our broadcast messages here is 127. So where we get that, okay, we're looking in the last octet, which is a little easier than those other two, which is in the third octet. But look here, we're just looking at the last 8 bits. Well, it was 96, and 30 of these are for the host, so just like we did before. So if you add 30 to 96, it's 126 plus 1. That's where that broadcast becomes 127. So here we have 8 bits of this 1022, and that's going to represent those full 8 bits there. So we only have 3 bits left from 8. So we get to 15, 3 bits that were added to that. And then this one up here, we already know 196 is 30 hosts on a portion of that, because over here it's all of those hosts that 255 would represent. So this is 127 because 96 gives us 30 hosts on this part of the network, which leaves us 127 there. Okay, I jumped over to the book real quick because in that last section on how to calculate these broadcast address, you might want to reference back to chapter 7 on that. So let's see, for number 3, again, the broadcast was 10.1.127.255, and where that comes from, again, is 96 means that there are 30 hosts that are from the 3 bits that we borrowed out of this subnet. But there's 8 bits from here, so that 8 comes to 255, and then, I'm sorry, not the 3 bits, the 2 bits, and then that's 30 hosts from 96 plus that extra one for the next available address is 127. One other site that I think is really helpful is Subnet mask.info. And you can use this to help figure out what your networks are. So if I put in, let's look at 10.1.113.75. And let's see, 10.1.113.75. Now we want some bit borrowing going on, so we don't want a class A by default because we want a subnet. You have to say how many number of networks do you want, or how many bits, how many hosts are required per network. So on this one, we already figured out that we want, the one I'm on, yeah. We want 8,190 hosts. So I'm going to go down to the next 8,192 minus the 2, and then we'll calculate it. And let's double check. It'll tell me what my subnet mask is. Oops. So here we're looking at this one. I just want to show that one. We're looking at this one. We plugged in this address. I'm sorry, this IP address. And then we said we want this many hosts because we know that. That's the next available number. So it says, okay, you have 19 for your network, and then the rest are for your host. So how many subnets does that give us? That gives us 2,048 subnets. And here's our subnet mask. And then if you, on this website, go to list networks, and even there's an explain, it'll list all of the different networks that you have, and then what the broadcast addresses are for each of those subnets. So you can see here, we listed 127 as our broadcast ID, so 10.1.127.255, which is this one down here. And that's because there's 30 hosts on each of the 2,048 subnets. And if we're looking at this network here, 10.1.96.0, and this is the network ID of .0, then our broadcast is the next hop minus that 1. So we have 30, or if you went up to 32, minus 1. So you can see the next network starts at 128. So this one goes from 96 to 127, and then 1 to 254 because we didn't borrow any bits of that last octet. So we have all 255 there. But we did borrow from that third octet, so that remains 127. And that's because our next network that starts in our subnets begins at 10.1.128. So I know that's a little confusing, but read a little bit more in your book on broadcast. Check out this subnet mask site because it is helpful in just checking your work and understanding things. But I think you hopefully have a better idea of subnetting at this point. I kind of wanted to keep this short, so let's look at the rest of this lab and see if you can do the rest on your own. Let me pause for a minute. Okay, continuing on with part 2, and I'm going to end this soon because I want to see how well you understand subnetting based on what we've done so far and breaking apart the binary. So starting part 2, calculate IP version 4 address subnetting. We're given scenarios. So we're given a network address, broadcast address, range of addresses on a subnet, number of subnets created, and then the number of hosts per subnet. So we're given this. You're going to find this information based on this information that we've learned. So what it means is if you have one network, you're a network administrator and you're given the 172.1677.120. That's your router IP. And then you're given it's a class B because it's 255.255.0.0. But what that means is you would have one network of 65,564 IPs, which doesn't work physically, so you need to subnet. So this becomes your new subnet mask. How many bits are we borrowing from that? Well, you just calculate how many bits from this 240. So we had 8 bits. 8 bits were part of our host, and then 240, that would be, looking at this table, 128, and then you add another bit and another bit and another bit till you get to your 240. So 1, 2, 3, 4, 0, 0, 0, 0. So you're borrowing 4 bits to get to that. So that tells us the number of subnet bits that you're borrowing is 240. Remember, these numbers never change, so 240 is always 4. Looking at our table here, 240 is always 4. 252 is always 6 bits that you're borrowing. You're going to figure out how many subnets are created, how many hosts are on there, and then the first and last host of each of those subnets. Now, that website I just told you is going to help you a lot, but it's going to better help you if you can figure out how to calculate that. Because 1, on your certification test, you're not going to have that. 2, if you understand subnetting, you're going to get a job. If you don't, you're not going to get a job. But in this lab, it explains this. Let's analyze how this table is completed, and it walks you through everything. Read through that, and then do these 6 steps. So there's 6 given scenarios. We'll do the first one together real quick. Okay? Problem 1, 2, 3, 4, 5, 6. Save your work, turn it in. And then reflect on why a subnet mask is so important to analyzing IP4 addresses. The first thing, the first reason is routers can't read ranges, they read numbers. So however many bits are in a subnet mask tells us how many what part of the IP is our network and what part is the host. So that's super important for routing our traffic to the right place. But read through that explanation because it does explain it. And then looking at this one, I'm going to give you the solution to this, and then you can do the rest on your own. Only check your work on subnetmask.info. Don't start off with that. Do some on your own. Check it to make sure you're doing it right. Remember, your 176 is your next class you're going to take probably next semester, and you'll be expected to know how to do this stuff here. So here, how many subnet bits? So for 224, 128 plus 64 plus 32, that gives us 224, so we're borrowing 3 bits, even though I typed 2. How many subnets does that give us? 8. How you can figure that out is 2 to the power of 3. 2 times 2 times 2 is 8. That's how many subnets we have. If we borrow 4 bits to the power of 2, that's how many subnets we have. 5 bits, we have 32 subnets. Okay. Number of host bits per subnet, 5. Read your explanation to figure out how that works. Number of hosts per subnet, how many hosts? Remember that formula? 30. We just did a bunch of examples. Network address of this subnet, the one that we're looking at, 192.168.200. We didn't borrow anything from the first 3 because our new subnet mask is the same, but we borrowed 3 bits from the last octet, so our new subnet mask is, or our new network address of this network, our network address of this subnet is 192.168.200.128. What's the first address? 192.168.200.129. Easy. Then we're going to jump ahead 30 minus 1, because we have 30 hosts on here. 192, so that's the last one, .168.200.158. So what does that leave as our broadcast? 159, you got it. 168.200.159. There you go. That's problem 1. I think you'll have a really good idea of how to do this lab now. Hopefully this helps, and I'll erase all of my junk in here, post this so you can have this conversion table. It'll help you with the packet tracer and your future exams and stuff, I think. Hopefully this video helped. Have a great day.